Elaborating on the idea of isotopes. Isotopes are the same element, so they have the same number of protons as each other, but they have a different mass. So they have a different number of neutrons. An example of two isotopes that we could look at, I could compare the two isotopes of chlorine, chlorine 35 and chlorine 37 are both isotopes of chlorine. I can add the 17 here too. Again, what you see on the periodic table is a weighted average of all of the chlorines in the world. It averages out to about 35 and a half. So if I wanted to ask you which one of these you think there's more of on Earth, if it was 50-50, the average mass would be 36. But it's not an average mass of 36. It's been tugged that way even further, down to about 35 and a half. And so this isotope must be more abundant. And really, if we were to split it up, it's about 75% chlorine 35 and about 25% chlorine 37. Okay, let's take a look at some practice questions. What is the average mass of copper on the periodic table? If you go to the periodic table, it's 63.5. Is it closer to 63 or 65? So what information can I conclude from that? Piece of information I can draw from that is that copper 63 is more common or more abundant than copper 65. Okay. Here's a sample problem where we're going to determine the average mass. This gives me the abundance of 3 different isotopes of neon. Of the neon in the world, about 90% of it is neon 20, about 9% is neon 22, and a smaller fraction of neon 21. When you want to determine the average mass, we're going to do something called a weighted average. I'm going to pair these two together. And I know that 90% of the of neon has a molecular weight of 20. So I'm going to, adding to my average, I'm going to turn that percentage into a decimal and multiply by the weight of the first isotope. I'm going to turn 0.27% into a decimal and multiply by the mass of that isotope. I'm going to turn 9.25% into a decimal and multiply by the weight of that isotope. This is going to give me the average mass. Okay, so I'm going to take my calculator, 0.9048 times 20 plus 0.0027 times 21 plus 0.0925 times 22 I get a value of 20.188. And does that make sense? If you look at what the mass of neon is in the periodic table, this should be pretty close. And so it's easy to check to see if your answer makes any sense. The reverse of this problem is one where we give you the mass of particular isotopes and ask you to figure out the percent abundance of each. I need to get the average atomic mass of calcium from the periodic table. So getting the average atomic mass of calcium from the periodic table gives me 40.08. So in the last problem, you knew these things and you didn't know this. And this is a reverse problem. What do I know about my percentages of anything? I know that my percent of this and my percent of that have to add up to equal 100%. So if I have the calcium 40, I'm going to call that X percent, or I'm going to call that X. And the calcium 46, I'm going to call 1 minus X, because I know that, or actually a better way to think of it at first might be calling this Y. I know that X plus Y have to equal 100%. 100% as a decimal form is 1. So that will be X, and that will be 1 minus X. These two numbers I wrote in green in that formula are my percentages in decimal form. Okay, so now I'm ready to solve it. 40.08 will equal 39.96x plus, over here I'm going to distribute 45.95 minus 45.95x. Collecting like terms. Combining these two numbers, I have negative 5.99x on this side. And I'm going to move this over to the other side. So 40.08 minus 45.95 leaves me with negative 5.87. I'm going to divide both sides by negative 5.99. And I get X is 0.9799. So that means I have 97.99% of the isotopes are calcium 40. And the remaining 2.01% are calcium 46, which is why the average on the periodic table is a lot closer to 40 than it is to 46.